Hello everyone. Today this will be our third session on 5G call flows, and today we will cover a very important KPI, which is 5G call drop rate, or also known as retainability KPI. This is one of the KPIs which is very complex because of the structure of 5G that we have. If you remember, the architecture of 5G, as we discussed in previous video sessions, is different than what we have in 4G or 3G. That is because currently the 5G is non-standalone. So the call flows that we then talk about, the drop rates and the retainability, they are not straightforward. So let's start and understand how this looks like. Um, Currently, if we have to categorize 5G drops, we can categorize them broadly into two major categories. One is the UE initiated drops, and the other is the G-Node B initiated drops. Now both of them have a different signaling flow, but let's understand what's the difference, and let's look at the overview. Now firstly, if you remember that previously we know that 5G in non-standalone mode, it means that the 5G node only carries the user plane data. So if there is user plane data, it will go through from 5G to the UE. However, if there is any signaling, it will go through from the LTE anchor node towards the UE. Now, what is signaling? Signaling means RRC signaling. So let's say if the 5G node needs to send the UE to another cell, let's say a handover. So how it will do? It cannot do it directly because the handover requires RRC signaling. It requires RRC reconfiguration messages, right? So what it will do is that it will have to ask the eNode B, the anchor eNode B, to request the UE to do the handover. So the signaling flow goes through like this, right? So this is an important aspect to understand before we start. I've already covered it in my architecture 5G architecture video session, but I just want to quickly recap that. Now the first kind of drop, which is a UE initiated drop. Now consider this UE is already connected to 5G, and it's already also connected to 4G on the control plane. So the user plane is over here and the control plane is over here. So if it fails, if it has a radio link failure, which is RLF, says that it cannot reach the G-Node B anymore, and the UE thinks that it has experienced a radio link failure, an RLF, then what it will do, it will send a message, an RRC message to the eNode B. The RRC message will be SCG failure information. Now the 3GPP specs have defined this. SCG means secondary cell group. Now when we add a 5G node, the 5G is considered an SCG, while the LTE is considered MCG, which is the master cell group, while the SCG means secondary cell group. So it tells the master cell group, which is the LTE anchor, on the RRC signaling that I have an SCG failure. And then SCG failure in 5G means a drop. So now this LTE node will then tell the 5G node to release this UE over the X2. So it will send an SGNode B release message towards the 5G GNode B, telling the 5G GNode B that this UE, which was connected to you, had an RLF, a radio link failure. So it's not connected to you anymore. Consider it a drop. So the 5G GNode B will use this message and peg a drop. So let's quickly recap this so that we are all on the same page. The UE finds out that it cannot connect to 5G node anymore, and it will say that okay, now I think I have a radio link failure. So it will send the SCG failure information, which is an RRC message, to the anchor eNode B, and the eNode B, the LTE anchor eNode B, will then tell the GNode B that this UE has had a drop on you, and then the GNode B will peg this as a drop, and this is called a UE initiated drop because the UE found out that it experienced a drop. Now another option is that the GNode B is unable to reach the UE. So the GNode B will think now that okay, I think I cannot reach this UE, so this UE has dropped in my as far as I am concerned. So the GNode B will then send a message over the X2 to the anchor eNode B telling the anchor e node B that this UE was connected to me, but I think it's not connected to me anymore. I think it has had a drop or a radio link failure. So please get it back to LTE. So the LTE, then the anchor e node B will then send an RRC reconfiguration to this UE, telling the UE that you no longer enjoy 5G services. You should come back to LTE now. Now, if you look at it from a simpler perspective, we can say that all uplink issues usually come out to be UE initiated drops, while all downlink issues, they come out to be as 5G GNode B initiated drops. So if you have more GNode B initiated drops, you can quickly sum up and say that okay, maybe I have issues in my downlink. And if you have more UE initiated drops, then you can say okay, most probably my issue is in uplink. So that is if we do a broad category of drops, this is how they will fall. But let's look at them individually to see what are the scenarios which will cause this problem and what are the scenarios which will cause this problem. So let's start. The first one that can be a part of this is the RACH drop. Now what is a RACH drop? In 4G or in other RATs, other technologies, RACH is a part of accessibility. And it is correct because RACH is the first thing the UE does. After that, it does the RRC connection and the ERAP setup. So RACH is part of accessibility in all other technologies. But in case of 5G non-standalone, a RACH failure turns out to be a 5G drop. Now why is that? The answer to that you can see in detail if you look at my first call flow video, which is the 5G accessibility video. In that we discussed that a UE, it connects to 5G and it connects to 5G mostly on the X2 interface. After this, it starts the RACH message. So the RACH preamble, it comes after the ERAB or the RAB or the bearer setup has been done. So you see the ENDC setup is already done here, and then the UE starts to do the RACH message. If I quickly recap this process, the 5G UE, it tells the e node B using a measurement report that it is within the 5G coverage, and based on that the e node B does the signaling over X2, which is SGNodeB addition request, and based on that the 5G responds with SGNodeB addition request acknowledgement, and then the LTE e node B tells the UE that okay, you can go to 5G now, and it shares the RACH configuration to the UE so that it can do the RACH to the 5G, and on the same time it sends the SGNodeB reconfiguration complete to the 5G GNode B, where we have ENDC setup success, and at this point we can say that the bearer has been shifted to the 5G GNode B. So if we have a RACH after this and the RACH fails, then what will happen? The UE will then send an SCG failure information to the anchor e node B, telling the anchor e node B that I tried to connect to this 5G GNode B, but it failed at random access. Now because the LTE anchor had already set up the bearer for this 5G system, so it will have to tear it down, and then it will send an SGNodeB release request to tear down the bearer, and it will transfer the UE back to LTE. Now since it has to send this SGNodeB release request, the GNode B will peg it as a drop because the bearer is already set up and this message is tearing it down. So that is why a RACH drop, a RACH failure in 5G non-standalone is considered a drop and not an accessibility failure. So I hope this clarifies. Now how do we find out whether this failure, the SCG failure information, is basically because of RACH or is it something else? So if you open this message, you will see the cause code, and these cause codes are defined in 3GPP 36331, and this one for random access, we have inside the SCG failure information, the cause code would be random access problem. So if it is random access problem, then you will know that the problem of the drop was caused due to a random access failure. So this is how we find out what kind of drop it is, and also we can see that this is a UE initiated drop. And it can happen, it usually happens if the UE is unable to send the RACH message 3 or the G node B is unable to decode the RACH message 3, but it can also happen if the UE sends preamble message 1 and the G node B is not able to receive that as well. So any failure among these three messages can cause a RACH failure, and that can cause an SCG failure information, which can then end up as a random access drop. So usually this happens because of bad coverage, or if you have, let's say, a very low B1 threshold, so you are letting very poor UEs enter the system, so they might meet the criteria of B1, but they might fail on the random access. So again, more or less this issue is related to coverage in most of the scenarios. Okay, the next one is uplink RLC drops. Now this is similar to what we had in LTE. So in this scenario, the UE already has done the RACH, and now UE is doing data on the 5G. So you can see that the UE is sending uplink data on the 5G G node B. So these green arrows over here, they indicate 5G signaling, or 5G data, 5G over the air data. So all these green indicates 5G data. So you can see that the UE is sending uplink data. Now consider a scenario where the UE is sending uplink data, but it is not able to get to the 5G G node B. So it is not able to get acknowledgements maybe, or it's getting negative acknowledgements. So that would mean that the UE knows that it is trying to send data in uplink, but it is failing. Now how it works out, we have MAC, which carries the HARC layer. So UE will transmit multiple HARC retransmissions. If all of them fail, then the higher layer, which is the RLC layer, it will retransmit the data. Then again, the UE will retransmit it over the HARC layer. If all the HARC retransmissions fail, the RLC layer will retransmit again. So it is configurable. The RLC layer can retransmit a configurable number of times. So if, let's say, I have configured it 4 times, let's say, so the RLC layer has retransmitted all 4 times, and the UE finds out that all 4 times it was unable to send this data, or is unable to send this data to the 5G G node B, or it was unable to reach the 5G G node B successfully. So in that case, the UE will say that, okay, I think I have a radio link failure in uplink, and it will initiate an SCG failure information to the LTE anchor. Now again, this one will have a different cause code. The cause code will be RLC max num retransmission. So it shows that the UE is saying that I have already tried the maximum number of retransmissions that the RLC layer permits, and I failed on all of them. So I think that I am having a failure, an SCG failure, so consider it a drop. So in this case as well, it will send an SCG failure information, and the E node B will then send an SG node B release request, which will be pegged as a drop on the 5G G node B. So this is another drop that can happen. Again, this can happen when you have bad uplink quality, for instance. So that can cause this problem. So you can there are multiple scenarios that you can do to tackle that, which we will discuss in further sessions when we talk about optimization. Okay, next one, poor quality drops. Now this one is a bit difficult to understand. It is similar to what we had in LTE, which is N310, T310, but let's understand how it works out on 5G. So again, the scenario is similar, where we have the RACH is successful. So now the UE is getting data on the 5G. So I can see that the downlink data on 5G is coming to the UE. Now the UE will keep monitoring the quality of the channel. If the UE finds out that the channel quality of 5G link is very poor, then it will initiate the N310 and T310 based failures. Now how does it happen? The UE keeps monitoring the SINR. How it gets the SINR? It gets the SINR from the SSB. So it keeps monitoring the SSB to get the RSRP and SINR. And if the SINR is very low, it thinks that at this SINR I will not be able to decode the PDCCH anymore, so it will consider it as 1 N310. Now if you remember, the SSB periodicity is mostly 20 milliseconds. So if I say that, okay, my N310 is 3, then it means that it will be actually the time duration will be 3 into N310 would be 3 into 20 milliseconds, which will be 60 milliseconds, because SSB comes every 20 milliseconds. So N310 is equal to 3 would mean 20 into 3 is equal to 60 milliseconds. So if for 60 milliseconds consecutively the SINR is so low that the UE will not be able to decode any PDCCH, then it will consider it that N310 has expired. Similarly, if I put my N310 as 10, then what will happen? It will become 20 into 10, 200 milliseconds. So that will mean that the UE will wait for 200 milliseconds, and if for 200 milliseconds consecutively the SINR is very poor, such that the UE will not be able to decode the PDCCH, it will trigger N310. Now, once N310 has been triggered, the UE waits for the T310 timer. Now, if the T310 also expires, then the UE sends SCG failure information, and if within the T310 there is another condition, which is the in sync, which is also called Q in. This is the N311. If during the T310 timer the N311 is fulfilled, then it stops the T310 timer and it goes back to its connection, and it does not initiate a SCG failure. Now, what is N311? N311 means that the SINR gets so good that the UE can now decode PDCCH. So it will consider it as an N311. Now, this is a simplistic view. In reality, in 3GPP 38133, this is defined as the UE will consider the SINR, the SSB SINR, to be below the threshold if at that SINR the PDCCH blur is more than 10%. So that is what the N310 or the Q out definition is as per 3GPP. And for N311, it will consider a SINR if the SINR goes above a certain threshold such that the PDCCH blur is below 2%, then we will consider it as N311. So let's take an example. Let's say the UE's SINR goes to minus 3 dB. Now the UEs know that at minus 3 dB, the hypothetical PDCCH blur would be around 11%. So it will wait for, if N310 is 3, it will wait for 60 milliseconds. And if 60 milliseconds the SINR still remains around minus 3 dB, so it will say, okay, N310 is triggered. Now, if T310 is also, let's say, 1000 milliseconds, so it will start the T310. Now, after some time, the SINR goes above 5 dB. So that means SINR is good. And at 5 dB, the PDCCH blur expected is around, let's say, 1%, which is below 2%. So the UE will say, okay, now this means that N311 criteria is met. So it will stop the T310 and it will go back to its 5G service, and it will retain the 5G service. If the SINR stays below the threshold and T310 expires, then the UE will send SCG failure information, and the cost code would be T310 expiry. And again, the eNodeB will then send SUNodeB release request, which will peg a drop on the 5G GNodeB. Okay. Now this is also a UE initiated drop, but it is more related to the downlink channel quality. So this is one of the differences in the categories. So it is a part of SCG failure information. It is the part of UE initiated drop, but it is more related to a downlink channel quality rather than the uplink failure. So this is something that we need to remember about this drop. Now I hope this is clear. If this one is more related to poor quality, so if you have these kind of drops, that means you have to optimize to increase your quality, increase your SINR. That should solve the issue. Or of course you can increase your N310 value or T310 value and reduce your N311. That should also help. Now another drop that we usually see or that we can say is the GNodeB initiated drop is the RLC drop in downlink. Now it is similar to the uplink RLC drop, but the difference here is that in this case the GNodeB is sending data in the downlink, and the GNodeB is not able to get any acknowledgement or any feedback, or it's not able to reach the UE, then the GNodeB will keep retransmitting. Now the concept is still similar, GNodeB will send HARQ retransmissions. If all the HARQ retransmissions fail, the GNodeB will go for the RLC retransmission. Again, for every RLC retransmission, the GNodeB will send the data over HARQ retransmissions, and once all the RLC retransmissions have failed, then the GNodeB will think that, okay, I think I cannot reach the UE anymore, so it is considered a drop. And in this case, the signaling flow is different. You can see that the GNodeB is now sending this message over X2 to the eNodeB, telling the eNodeB that sGNodeB release is required. And at this point, GNodeB will also peg a 5G drop. So over here, the difference here is that now the GNodeB finds out that there is a drop. It sends the message to the eNodeB, and then the eNodeB will over here send an RRC reconfiguration to the 5G UE, telling the UE to get back to LTE because the UE is no longer getting 5G services. So this is how the downlink RLC drop or a GNodeB initiated drop will look like. So these are the major kind of drops that we have, and these are the call flows that we have. So we'll talk about optimization in the future sessions, but this is the if you look at the call flow perspective, and if you want to understand what happens in each kind of drop, you can understand from this. So I hope this helps. I hope you will like it, and I hope if you do, please do share with your colleagues, do subscribe, and see you soon. Bye bye.